Ponnu Murugan.
Thank you, Your Honor. Thank you.
You proceed.
Your Honor.
Thank you, Your Honor. Thank you. Hello everyone, it's me Arvind catching you on another Tutor Edu's lecture video. Okay, we have come to the final part, which is the part 3, area of sector and area of segment. Okay, in the previous two parts, we have literally covered the radian, length of arc and perimeter of segment. Okay, if you haven't watched those two videos, okay, please click on the link above and watch those lecture videos first, and then you come back to this part 3. Okay, so let us start our lecture video now. So we're going to start by covering the area of sector of a circle. So let me draw a sector first. Okay, so please give me a moment.
Five minutes later.
Okay, so from here, let me draw the angle here. So the internal angle is theta and this is the radius. Okay, so this piece of a circle is known as a sector. Okay, this piece from the complete circle, what I mean guys, okay, it's known as sector. Okay, so we are required to find the area of this sector. So how to find the area of a sector? Okay, so to find the area of sector, we're going to apply this formula. Okay, this is the first time we are learning it. So the area of sector will be equals to half times with r square times with theta. Okay, remember guys, this theta is in radian. Okay, so make sure that when you are solving the circular measure problem, okay, especially in the area of sector of a circle, so you must have the angle in radian. Okay, throughout this chapter you mostly handle the angle in radian guys. Okay, that's why it is important for you to learn how to convert from degree to radian. Okay, so let me box this formula. So this is the first part. Okay, so if I just leave it you in this way, you might not able to appreciate this formula. So how are you going to strongly prove that the area of sector formula is applicable? Okay, let's say for example, we will take an angle of a circle, an internal angle of a circle. So in this case, so total internal angle of a circle, okay, in this case is 360 degree. But since we are dealing with the circular measure and we are going to apply the area of sector formula, we can't just write 360 degree. So we need to convert this into a radian form. So if you convert this into radian form, it will be 2 pi radian. Okay, so we're going to apply this angle into this area of sector formula. Okay, so from here your area of sector will be equals to, of a circle guys, okay, so will be equals to half times with r square. Okay, your angle theta in this case is 2 pi. Okay, so the 2 you simplify, you get 1. So these 2 you simplify, you get 1. So from here your area of sector is equals to pi r square. Quite familiar, right, this formula? So this formula is actually an area of a circle. So this way you get the area of circle guys, okay, through this method. Okay, so from here your area of circle is actually equals to pi r square. So basically you apply the area of sector and you apply the total internal angle of a circle and you substitute in, and that's how you get the area of circle. Okay, so let me box this as well. Okay, by the way, this is for your extra knowledge guys, okay, for your understanding. Wait, let me undo this and draw a bigger box. Okay, so this is the way how you get a area of circle. Okay, so pi r square. So okay, let us go through one example. Okay, we're going to use this same sector, so let me just copy paste this. Okay, so, and you know what, okay, this one I remove, okay, this one I remove, okay, this one I change it into 1.5 radian. Okay, so the radian I leave it blank, I mean the radius I leave it blank. Okay, the area, okay, I put it here as 90 centimeters square. So how to find the radius? Okay, for example, so from here let us apply the area of sector formula here. So let me just copy paste this. Okay, so from here your area of sector you already know is 90 centimeter square. Okay, just write 90 here. So the radius we don't know yet. Okay, we just leave it here r square. So from here half times with r square. Okay, this theta is already give us to us is 1.5 radian. Okay, 1.5. Okay, so from here you times the equation 2 at both sides. Okay, so from here you get 180 is equals to r square times with 3. Okay, so from here r square is equals to 180 you divide with 3. So 180 you divide with 3. So from here you get your r square is equals to 60. Okay, so r square is equals to 60. So to get your r will be equals to square root 60. So you calculate this, you should get your r is equals to, okay, so let me take out the calculator. So square root 60. Okay, so this is the exact value. Okay, so this is the value in decimal. So 7.74596. okay, and it's going on. So we take up to 2 decimal place. So your r will be 7.75 centimeter. Okay, approximately 7.75 centimeter, guys. Okay, so this is the very simple example that they can possibly ask you. Okay, but this is for your understanding, but in exam you can't expect the question to come this easy, guys. Okay, it will come a bit tough. Okay, so I hope you understand the working till now. So let me give you another example. Okay, in this case let me draw a circle. Okay, so let me draw a straight line. Okay, so another straight line. Okay, so let me just label here A and B. Okay, so the radius is given as 7 centimeter. Okay, so from here this major sector we shade it. Okay, so in the question the major shaded, I mean the major sector, they already gave us the area, which in this case, okay, let me refer this. Okay, 106.92 centimeter square. Okay, so we need to find the length of the minor arc AB. So the question asks you to find length of minor arc AB. Okay, by right now, if you don't know what is a minor arc, in this circle, okay, this region from here to here is the minor arc. So from here, the big circle up until here, this is the major arc. Major arc, minor arc. Okay, is that clear? So the question asks you to find the length of the minor arc AB. Okay, so in order to find the length of the arc AB, so what you need to have? You need to have the angle. But do we know the angle? We don't know the angle. Okay, however, they already gave us the area of the major sector, 106.92 centimeter square, and they already gave us the radius. So can we find the area, the angle of the major sector? Yes, we can find. Okay, so that will be our step 1, guys. Okay, so that is how you approach a question, guys. Okay, I'm literally teaching you how to approach a question. So step 1, find angle. Okay, so let me just write here O, guys. Okay, center O. So angle of AOB. Okay, in this case, the major angle. Major angle. Okay, so to find this, we're going to use area of sector formula. Okay, so from here, area of sector is A is equals to half R square times with theta. Okay, so from here, area we know that is 106.92. Okay, so we apply the formula, so half, okay, times with radius, okay, 7 square. Okay, and then the theta, do we know the theta? Do we know the major angle? We don't know yet, so we just leave it here as theta. Okay, so you times the equation by 2 on the both side. So from here, okay, so 106.92 times 2. Okay, so from here you get 213.84. Okay, 213.84 is equals to, okay, so from here 7 square you get is 49. Okay, when you times the equation by 2, the 2 and 2 will get cancelled off, so it will only become 1. So 1 times it 49, so that's how you get 49 here. So 49 theta. Okay, so 49 theta is equals to 213.84. So to get theta will be equals to 213.84. You divide with 49. Okay, so let us calculate. So 213.84. Wait on, guys. 213.84. So divide with 49. Okay, calculate this. So from here you get 4.3641 radian. 4.3641 radian. Okay. Okay, guys. So let me underline the major sector angle. Okay. So once you get this, so your next step is finding the angle of the minor sector. Okay, to find the angle of the minor sector, so what you do, so the area of the complete total internal angle of a circle, you minus with the angle of the major sector. So from here, angle of minor sector So from here will be equals to 2 pi minus 4.3641 radian. Okay, you calculate this. So let us perform the calculation. Okay, so 2 pi minus 4.3641. Okay, so from here you get 1.9191 radian. Okay, 1.9191. Okay, 1.9191 radian. Okay, so let me underline this. Okay, so this is your second step. Find the angle of minor sector. Okay, so let me just write this as step 2. So from here, step 2, find angle of minor sector. Okay, so once you get this, then only you can use the angle of the minor sector. Okay, you have the angle, you have the radius. Can you find the minor arc AB? Yes, you can. So we have come to the final step. So step 3, find SAB, length of the arc AB. Okay, so from here, so we're going to apply the formula S equals to R theta. Okay, so use the formula S equals to R theta. So let me box this. Okay, so S we don't know yet, so that's the one we're going to find out. So SAB, so it's equals to radius. How much is the R? The R is 7 centimeter. Okay, how much is the angle? So 1.9191. Okay, times with 1.9191. Okay, so you calculate this. So from here you get the length of the minor arc AB is, so let me open the calculator. So 7 times with 7 times with 1.9191. Okay, so you calculate this. So your length of minor arc will be 13.43 centimeter. So this will be your final answer. So 13.43 centimeter. So this is your answer for the second example. Okay. So if you find it difficult, okay, don't worry. So take it slow and steady. Okay, try to understand how to approach the problem, guys. Okay, in the beginning you might find it overwhelming, but as you go through more practice, you will get the trend of this chapter. Okay, this chapter, the formula is very straightforward, but it's not about the formula, it's about how you approach the question. Okay, we still have one more concept to cover, which is the area of segment. So from here, okay, let me just copy paste this diagram. Okay, so from here, area of segment, okay, so let me underline this. Okay, paste sector. Okay, so from here, let me just add a chart over here. Okay, and I shade this minor segment. Let me shade this segment over here. Okay, so now let's say if a question asks you to find the area of a segment, so how theoretically you need to find it. Okay, so the first step is we need to find the area of a sector, okay, which is this region. okay, and then you find the area of a triangle. So as you can see here, this white region is following the area of triangle. Okay, you find those two area and then you minus them together, and that's how you get the area of segment. Okay, so theoretically, so this is the idea on how we're going to approach the area of segment. So similar way on that, we're going to apply our formula. Okay, so the formula to find the area of segment, so area of segment, okay, will be equals to area of sector minus with area of triangle. Okay, in this case will be half r square theta, okay, and then minus with half r square sine theta. Okay, so this concept you learn during your form 4 solution of triangle, guys. Okay, in that chapter you will learn how to find the area of triangle. Okay, let's say so you have length, two consecutive length, and you have an angle, so you can use these two information to find the area of triangle. Okay, so I hope you recall back the concept you learned during the form 4 solution of triangle. Okay, so this area and this area you minus them together, so that's how you get the area of segment. Okay, so this term we can further simplify. So what you're going to do is the half r square we can factor out. Okay, half r square you factor out, so you only left with theta minus sine theta. Okay, so this is the simplified way. Okay, so all right, just give me a moment. So let me adjust this for me to box the formula. Okay, so let me box this formula. Oops, now it's better. Okay, in this question, so we're going to find the area of segment, okay, AB. So how are we going to find? So we're going to apply the area of segment. Okay, so from here, area of segment, okay, is equals to half r square, okay, in a bracket theta minus sine theta. Okay, so continue. So let me just write in this in short form A or S. So it's equals to half, okay, times with 6 square, okay, and let me include the angle. So 1.4 minus sine 1.4. Okay, so let us calculate this. Okay, so from here 1 over 2, okay, 6 square, okay, and then before you include the calculation of 1.4 minus sine 1.4, check whether the mode is in radian form or degree form, guys. Okay, if it's in radian form, okay, you proceed. If it is in the degree form, make sure you convert into the radian form. Okay, so this is the important thing I would like to tell to the student. Okay, so let me continue the calculation. So from here 1.4 minus sine 1.4, close bracket, close bracket. Okay, so from here you get your area of sector is equals to 7.46190,486. Okay, so you will take up to 2 decimal place. So from here your answer will be 7.46 centimeters square. So from here 7.46 centimeter square. So this is your area of segment. Okay, it is pretty straightforward. So basically, so that is the concept of area of segment. Okay. Okay, let me check whether should I go with another example or not. Okay, you know what? You'll go with another example. Okay, so more example means more exposure to the students. Okay, one more example, guys. Okay, hang tight. Okay, we go for another example. Okay, similar AOB. So the angle this time we change it into 1.5 radian. Okay, so this one we remove. Okay, now we give the length of arc AB. Okay, which in this case is 12 centimeter. Okay, so the question asks you to find the area of segment. Okay, so how are you going to find? So in this question, they already give you the length of the arc AB, which is 12 centimeter. Okay, they already gave you the internal angle, which is internal angle of the sector, which is 1.5 radian. So how are you going to start? Okay, so the first step, what you need to do is you need to find the radius of the sector. Okay, so once you find the radius of the sector, then only you can use the area of segment formula, and then you can able to find the area of segment. Okay, so step 1, find radius. Okay, so find radius. Okay, so from here we're going to use S, sorry guys, it's hanging. S is equals to R theta. Okay, so S they already gave us is 12 centimeter. Okay, R we don't know yet, that is the one you're going to find out. Okay, theta they already gave us is 1.5. So from here to find your radius will be 12 divided with 1.5. Okay, so you calculate this, you should get your R is equals to, okay, so from here 12 divided with 1.5. So from here you get your radius is 8 centimeter. So that is your step 1. So let me underline this. Okay. Okay, so once you find the radius, okay, now you can use the area of segment formula to find the area of segment AB. Okay, so step 2, find area of segment. Okay, so we're going to apply the formula half, okay, times with R square, okay, in the bracket theta minus sine theta. Okay, so from here 1 over 2, the radius we have already find in the step 1, which is 8 centimeter. So half times with 8 square, okay, and then the theta, okay, which is 1.5 minus sine 1.5. Okay, so you take out your calculator, so you perform the calculation, but before that check whether it's in the radian form or degree form. Okay, if it's the radian form, you proceed. 1 over 2, okay, and then bracket times with 8 square, oops, okay, and then you times with 1.5 minus sine 1.5. Okay, close bracket. So you calculate this, you should get your answer is 16.08 centimeter square. So this is your area of segment. Okay, 16.08 centimeter square. Okay, sudah habis. Okay, so we have come to the end of our lecture for Form 5 Chapter 1 Circular Measures. So I hope you have understand all the material that I've taught to you, okay, all the concepts from radian until the area of segment. So this chapter, technically it's easy, but it requires you lots of practice. Okay, so you exposed with more types of questions. Okay, by the way, I've uploaded many types of circular measures questions with a step-by-step explanation, so you can take a look at them in the playlist. Okay, so if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future. And if you are a student, make sure that you share this video to your friends, okay, so that people will get to know and they will benefit from it. Okay, so thank you guys for your support, and I'll see you in the next video.
Bye, have a great time.